Good afternoon everyone, and welcome to the first of today's worked exam answer videos. In this question I am having a look at addition and condensation polymers. Now this has specifically come from an AQA GCSE paper, but this content could also be asked in an A-level AQA paper as well, where the addition polymerization comes up in the year 12 component, and then the condensation polymers topic is a part of the year 13 specification. As a GCSE topic, this can also come up in the Edexcel iGCSE triple award content, and I imagine that either the first or both aspects of this will also be in other GCSE specifications as well. So this is essentially a video for probably quite a lot of you. And in this question, we are first of all thinking specifically about addition polymerization and how we can use an ethene monomer, so an alkene, to produce polyethene. Then it gives us a bit of an equation to represent a different type of polymer, and then we've got to answer for a slightly longer question, kind of how the types of polymerization differ, if there's any points that are the same about them, and compare the two types of polymerization, essentially. So, first off, we can use alkenes as monomers to make addition polymers. Now, the name addition polymers is really helpful because what we do with our alkenes is we add a very large number of these alkene monomers together. Now, what we're being asked to do in this question, and this is a very, very common type of AQA GCSE question, is we have to put the bonds in to the ethene originally and then have a think about what the polymer of the polyethene will look like afterwards. So we've got to complete the displayed formulae. Displayed formulae show all of the atoms and all of the bonds, so they've already drawn the atoms for us. We have to put all of the bonds on. So ethene being an alkene, we're going to need a double bond between the carbons there, and then we're going to need single bonds between the carbons and the hydrogen atoms like that. Now that N in front of that monomer just means that we can join together any number at all of these monomers to make a polymer of polyethene. Now, N will be a very big number, sort of in the hundreds of thousands, millions of them, and the N that we can see outside of the brackets in the product, whatever this value of N is, that will be the exact same value here. Now, when we represent the polymer, we have the repeating unit inside of these brackets, and again the N is referring to the fact that the polymer will be made up of however many hundreds of thousands or millions of repeating units that we have. So the repeating unit is the singular part of the polymer that we see over and over and over again, and then the polymer is the combination of all of those repeating units where we're considering the whole of the product. Now, when we do addition polymerization, which is what we're doing here, as I said, we need to add these ethene monomers together. Now, the word monomer just means a small unit, and an ethene monomer is a very small unit because it's only made up of 2 carbons and 4 hydrogens. The idea is we're going from something that is small and individual to something that is long chained and all joined together, which is what we kind of think of as a polymer. So in order to join these monomers together, we have to break the carbon-carbon double bond, because otherwise each carbon atom has no spare bonds with which it can then use those to join on to other ethene monomers. So in addition polymerization, we break open the double bond so that it becomes a single bond in between those carbons. We do nothing with the carbon-hydrogen bonds, so they stay as is. But because each carbon was originally bonded to the other one twice and it's now only bonded once, that gives each of them the ability to have a new bond to another broken up monomer. And these bonds that I've drawn out the side, those sometimes called continuation bonds or the trailing bonds, And that shows that once we've opened up the double bond in the monomer, we get this repeating unit, and then that can join onto another opened up monomer, and another and another and another and another. And it's really important that these trailing or continuation bonds go through the brackets. That is something that they will look for, and they might penalise you for if you don't do. And then, yeah, for the polymer, we would always want to have the brackets and the N. If we're just doing a singular repeat unit, we wouldn't need the brackets or the N. So that's what we need to do for the addition polymerization component of this question. Then in part B, it says that polyesters are made from a different method of polymerization. So this is where we're thinking about condensation polymerization. Now they've given us a bit of a generic equation that can be used to produce a polyester. And what we can see here is, again, we're using N, lots of monomer, but here we're actually using two different types of monomer. So we're not just using one type of alkene monomer and adding that together over and over again. We're actually using two different types of monomer here. And what we can hopefully see is that one of them has a Q group on each end of the chain, and the other has an OH group on either end of the chain. Now, you might be wondering what these rectangular boxes are doing in between the OHs and in between the Q groups. Those are just there to show that it really doesn't matter how many carbons are in there. It needs to be at least one in between the two alcohol groups, and that might just then be a C with a H up and down, or it could be two C's with H's up and down on both, or three C's or four C's or anything. That's the point. It really doesn't matter what that rectangular box is representing. Likewise here, we could actually just have the two Q groups bonded together. We don't need to have a carbon in there, but we could have one carbon in there, 2, 3, 4, 5, 25, 205. It really wouldn't matter. The important thing for making polyesters is that we have an alcohol that has two OH groups, so we can call that a diol. So we've got two alcohol groups, and I'll just write alcohol above. And this is where knowing our functional groups for our organic compounds is important, because we need to spot straight away that the OH is an alcohol. And then the Q group is the functional group for our carboxylic acid. So because we've got a carboxylic acid on either end of the chain, we could call that a dicarboxylic acid. And we were told that we're trying to make polyesters. So when we think about, again, the reaction between a singular OH, alcohol functional group, and a singular Q, carboxylic acid functional group, we can react alcohols and carboxylic acids together to make esters. And the ester linkage is the COO that we have there and there. So this is a polyester because not only do we make one ester linkage between the OH and the Q group on one end of my alcohol and my carboxylic acid, we then have the OH and the Q group at the opposite ends, which then enable us to make more ester linkages. And again, same idea in that we've got a repeating unit, and that repeating unit, singular, repeated over and over and over again, will give us our polymer chain, with the N there representing the same N for our alcohols and our carboxylic acid monomers that we use. Now, one of the things that's different with condensation polymerization is, whilst yes, we are kind of adding the monomers together, this is a condensation reaction, hence condensation polymerization, because we are removing water. So the OH alcohol will lose a hydrogen when it joins onto the carboxylic acid, and the carboxylic acid will lose its OH. So we're going to take the OH off of both of the Q groups, and we're going to take the H off of both of the alcohol groups. and that's where our 2N lots of H2O come from, because we're going to have the 2 H's from each OH alcohol, and we're going to have the 2 OH's from each of the carboxylic acids Q groups. So we will always get twice as much water being made when we join a diol with a dicarboxylic acid. Now, there's a lot of things that I've already said that will help me to answer this question, which is compare the polymerization reaction used to produce polyethene with the polymerization reaction used to produce a polyester. So compare is obviously thinking about the similarities and differences, and there are certain things that are similar in regards to adding N lots of monomers together and having a repeating unit, having the continuation trailing bonds, to show that we have that repeating unit over and over and over again, that sort of thing. But I think actually there's quite a lot of differences between the two types of polymer. Now I'm going to answer this in bullet points. And what I'll do is when I refer to the addition polymerization, I'll use purple. And when I'm referring to the condensation polymerization, I'll use orange, just because I think it's a bit clearer than the yellow. Okay, so polyethene is produced via addition. Polymerization. Whereas polyesters are produced via condensation. Polymerization. Now, you would never have to name a specific polyester in the same way that you would be expected to recognise that this is polyethene. When we're naming addition polymers, we put the name of the alkene in brackets and stick the word poly in the front. With polyesters, we'd need to be thinking about the specific ester, which of course is going to vary depending on what we have in these rectangular boxes. So we would never be asked to do that. So if that's something you were wondering, don't worry. You will need to know how to name esters when we make them just from a normal alcohol with 1 OH and a normal carboxylic acid with 1 Q. Particularly, they want you to know about ethyl ethanoate or ethyl ethanoate, however you've kind of heard of it. So that's the specific one, but I definitely recommend being familiar with how to name esters generally. So that's one point. Then we can have a think about the monomers. So we've got one monomer for addition polymerization and one type of monomer, but for polyesters we've got 2 different monomers that are, different from each other. Excuse me. So that's the next thing that we can write about. So addition polymerization uses only one type of monomer, which is an alkene, whereas condensation polymerization uses 2 types of monomer. Our alcohols and carboxylic acids. Okay, Another thing we can think about is the products. So when we do addition polymerization or any addition reaction, we will only get one product, whether we're adding two different things together or two of the same type of thing together. Any addition reaction, sounds a bit silly to say, but we are just adding them together. Nothing is being swapped off, nothing is being kicked out, there's no substitution, there's no elimination, it's just two things becoming one. So the addition polymer will be the only product there, whereas in condensation polymerization, we've discussed where the waters are coming from. We have to remove those atoms in order to form the ester linkage. So as well as getting the polyester, we get water. So that's another difference in the number of products that we get. So addition polymers are the only product of the reaction, whereas condensation polymers are formed alongside water, so not the only product, or two products. And because this is 4 marks, I'm trying to think of I'm thinking of and writing down 4 things that are different. So we've got addition polymerization versus condensation, we've then got one type of monomer versus two types of monomers, we've got only one product, and then we've got two products. And then the final thing is thinking about what we've then got within the polymer itself. So when we've got all of our monomers, our ethene monomers joined together, we then have this sort of alkane hydrocarbon based chain because we've got polyethene. It might be that you have hydrogen atoms bonded to the carbons, but here we've certainly got like an alkane chain, whereas in our polyester we have an ester linkage, which again is different. We don't have an ester linkage in our polyethene, and we never would have if we were using alkene monomers. Likewise, we could never just have like an alkane based chain in making a polyester, because those things then just wouldn't be what they are. So addition polymers are long chain alkanes, whereas condensation polymers contain ester linkages, which is the C double bond O, single bond O, like that in the middle. So that's what the COO, as they've represented it in this diagram, would actually look like. Okay, and that will do us for our answer to that question, because we've mentioned 4 things that are actually all different about these types of polymers, and whilst the representation of the polymers is the same, they are actually quite different, addition and condensation polymerization. Now, if anybody has any questions about that, of course, please don't hesitate to get in touch. You can leave a comment on the video or send me an email to missgtutoringendresources@outlook.com. Sorry, I had to think of my own email address then. But yeah, any queries, please just ask. And thank you so much for watching. Take care, everyone.